copied and pasted this table into here, and I put that 2 there because I forgot on the other page. So we have to figure out, again, if it's linear, exponential, or quadratic. And I probably could have given you more examples, but this will be okay. So basically, I'm going to go through this chart. And I'm first going to figure out if it's linear. If it's not, I'm going to figure out it's exponential. And if it's not exponential, I'm going to figure out it's quadratic. So it's kind of hinting on in the other video. This is just kind of how we're doing it. So it says the first difference is consistent. So if we found the first difference, between these two numbers, you're saying what's the difference? Well, there's no difference because it's the same number, so it's 0. If I ask you what's the difference between here and here? Well, what's -4 minus -6? Well, it's +2, right? And then what's 0 minus -4? Well, it's 4. And 0 and 6 is 6. All right, so these aren't consistent, and we do know that these are going up by 1, so we're good there. So for that reason, the first difference is consistent. That's not an option. It's not linear. But there's something you should notice, and you should notice that there's a repeat of numbers. And right here it says the never the same y value twice. Okay? Well, you're able to find the difference of these by subtracting, and they're not multiplying up. So automatically it's not exponential, but it also says never see the same y value twice, and we do. The only one that allows it, I'm going to go over this, I guess that makes it all the same color. The only one that does allow it to be twice is quadratic, and that's because it's a parabola. So right there, it is proof that this is a parabola. But I'm going to take one step farther just to show you what it means by the second difference. So the second difference means you're going to take that more right value because of, like, if you were graphing this, 0 is more right than -1, correct? So we take the larger x values first, and subtract with the y values. It's weird to say that. So you're basically taking 2 minus 0, 4 minus 2, 6 minus 4. Just watch your x values. The difference between 0 and 2, well, that's 2. It goes up 2. Same for 4 and 2, and same for 6. Well, we notice that they have the same second difference. So that's what it means by second difference. So it means find the difference between the y values given, and then find the difference between those differences. So for 2 reasons, this is quadratic. Okay, and I'm going to get rid of this because it is in my way of the next problem. All right, so with the next problem, we have to see, is there a common difference? Or is there a difference between it? And common differences you can say. So 0.4 minus 0.08 is 0.32. And 2 minus 0.4 is 1.6. So automatically it's not linear because there's no consistent difference between it. So linear is off the table. So if there's not a common difference with the linear, then there's not going to be with the quadratic. I mean, to an extent. You can find the difference, but like what we had isn't going to have a second difference that are the same. What you should notice is these values are going up pretty fast. And that value is going up pretty fast because they're being multiplied by something. So just to prove it with here, 2 to 10, because it's not a decimal, it's easier to see. 2 and 10. 2 is multiplied by 5 to get 10. So what I did is I did 10 divided by 2, and that's 5. Well, what about these two values? Well, you're going to take 2 divided by 0.4. And you take 2 divided by 0.4, you also get 5. So it's being multiplied by 5. And if you take 0.4 divided by 0.08, that also is 5. So these are being multiplied by 5, and since they're being multiplied, the only one that multiplies is exponential. Okay, so let's go ahead and move on to this next example. So they want you to graph it, so that's not too bad. And then we're going to try to come up with an equation, which that will definitely be fun. So let's go ahead and just do number 4 and see how this goes, and then I will have another video for 5 and 6. So I'm just going to do a few of these examples in each video. So I'm going to graph -2, -7. I'm going to graph 0, -3, and 1, -1, 3, 3, and 5, 7. Okay. This should automatically say, okay, this is definitely a linear graph, right? Okay, I'm not going to cover that up quite yet because I want you to see these points. The question is how do you come up with it? Well, first off, we decided it was linear, right? Well, what's the equation? Well, when we did linear equations, we did y equals mx plus b. And if you remember, m is the slope, and that's found by y2 minus y1 over x2 minus x1, or rise over run. And b is the y-intercept. Remember, it's weird because it's a French thing, so the letters aren't right. So to write this equation, and we know it's a linear, the first thing we can say is, okay, we know what the y-intercept is, and it's right there. Okay, so I'm going to highlight that just to keep this in mind. That is the y-intercept. It's been a while since we did this. So because of it, it is -3. And then we're going to figure out the slope. So we're going to go up and over. So it goes up 1, 2, 3 over 1. Correct? Okay, let's just check the other ones. This goes up 1, 2, 3, 4 over 2. Wait. Oh, sorry, I counted that wrong. It went up 1, 2 over 1. So right there, it's saying the slope is 2. And I just want to check. And if we go up from here, it goes up 1, 2, 3, 4 over 2. Well, 4 divided by 2 is 2. So our slope is positive. It's going in an upward trend. So it's positive 2, and then we put the x. Okay. So that's the end of the second video. In the left-hand corner, you should see a link for the next 2 examples.